In this video, I'll show you how to know when a function is increasing or decreasing using calculus. This is part 1 of the series. So suppose you are given f at x is equal to 2 times x to the power of 3 minus 3 times x to the power of 2 minus 12x. How would you sketch this? Now we know that plotting points is tedious, and using graphing software may miss some important features on the graph. However, combining what we know about domain, range, intercepts, vertical and horizontal asymptotes, maximum and minimum, we can accurately sketch functions. The first thing to keep in mind is the increasing and decreasing test. This test tells us that if f prime at x is greater than 0 on an interval, then f is increasing on that interval. Similarly, if f prime is less than 0 on an interval, then that function is decreasing on that interval. Let me show you what I mean with this question. This question will also be used in part 2. Find where the function f at x is equal to 2x to the power of 3 and so on is increasing and where it is decreasing. The first thing that you'll have to do is find the derivative. Let's find the derivative by using the power rule for all three terms. Minus 6x minus 12. The next thing I'll do is factor this to find out the zeros. So I'll set this to 0 is equal to 6x squared minus 6x minus 12. And by doing that, I end up with x squared minus x minus 2. Now, we use common factoring here. What two numbers multiply to negative 2 and add to negative 1? If you chose negative 2 and positive 1, you're correct. 6x, negative 2, x, positive 1. And now we're going to solve for our x's. We get two x's, the first one being positive 2 and the second one being negative 1. So, using the test above, we can find out when the derivative of this function is increasing by substituting values that are smaller than negative 1, in between negative 1 and 2, and values that are greater than 2. And this will tell us when the function is increasing or decreasing. Let me demonstrate. Let's start off by inputting a number that is less than 1. So, a number that is less than 1 when x is less than 1 gives us 6 times negative 2, I just chose an arbitrary value for x, minus 6 times negative 2 minus 12. This gives us an answer that is positive. And when we try a number that is between negative 1 and 2, let's say it's 0, we end up with a number that is negative. And lastly, when we try a number that is greater than 2, we get a number that is positive again. Therefore, according to this test, here, when you have negative infinity to negative 1, it is increasing. And when you have negative 1 to 2, it is decreasing. And when you have 2 to positive infinity, it is once again increasing. Let's continue. What's happening at the points x is equal to negative 1 and x is equal to 2 in our above example? At these points, f prime at x is equal to 0. These are candidates for local maximum and minimum values. Now, to find out, we're going to use the first derivative test. The first derivative test tells us that suppose c is a critical number of a continuous function f, and the critical numbers we found were negative 1 and 2. If f prime changes from positive to negative at c, then f has a local maximum at c. If f prime changes from negative to positive at c, then f has a local minimum at C, and if f prime does not change at sign C, so for example, you got positive and positive or negative and negative, then f has no local maximum or minimum at C. So we can pretend that it went up, and there you had a local maximum. And then in between -1 and +2, it went down. So we can assume that there was a local minimum. And lastly, from 2 onwards, it increases again. So those are the assumptions we can make to find out local, minimum, and maximum values. So that concludes part 1 of this video. In part 2 of this video, I'll continue to show you how to sketch a function using the points that we found here in addition to the ones that we will discover in that video. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.